Hello, this is Mrs. Ward, and I am going to go over the problems for the first half of the homework on section 2.3, finding the derivatives using the product, quotient, rules, and then doing higher order derivatives. So this is just the first half, so here we go. The first one, use the product rule to differentiate the equation. So remember, I have two parts to this. I have f of x, which is going to be this x to the third, and I'm multiplying by g of x, which is this cosine of x. So you're going to do that. You're going to do the product rule where you find the derivative. We're going to leave f of x alone. So I'm going to leave the x to the third alone. And I'm going to take the derivative of cosine, and remember the derivative of cosine is negative sine x. So I'm going to put times negative sine x, and then plus, and then I take the derivative of f of x. Well, actually, take the new g of x alone if I'm following that pattern, and I'll take the derivative of f of x, which will be 3x squared. I never write it that way. And so when I do this, I'm going to have the derivatives equal to negative x to the third sine of x plus 3x squared cosine of x. And then I'm going to have to simplify some of these. And this one, what I can do is I notice that I have a common factor of x to x squared, so I'm going to factor that out. So my derivative simplified will be x squared. You can even factor out a positive x squared and negative x squared. It really doesn't matter as long as you keep your signs correct. This will be negative x sine x plus 3 cosine x. And that's the derivative. Going on to the next one. Number 8, you're still finding the derivative. You're using the product of the quotient rule. This one I'm definitely going to have to use the quotient rule. So again, this is going to be my f of x. This will be my g of x. And I'm going to follow that pattern. So to find the derivative, I'm going to leave g of x alone. So this 2t minus 7 stays the same. Take the derivative of t squared plus 2, which is just 2t. Put a minus sign. Now I'm going to take the derivative of the denominator, which will be 2, and leave f of x alone. So this is t squared plus 2. And this is all over my denominator, 2t minus 7. That whole thing is squared. Now I have to simplify. So I'm going to distribute the 2t, and I'm going to have 2t squared minus 14t. Here I'm going to distribute a negative 2, so minus t squared, 2t squared. Minus 4. Just realized that I made a mistake. Oopsie. Well, here I'm going to erase, actually. Let's erase. This, when I take 2 times 2t, this should have been 4t squared. Sorry about that. So that'll be 4t squared. And this is all over 2t minus 7 squared. Now when I combine my like terms, the 4t squared and the negative 2t squared will be 2t squared minus 14t minus 4 all over the parenthesis of 2t minus 7 squared. Now I should check to make sure nothing simplifies, like I can't product sum this. So the first thing I'm going to do is factor out a 2. And when I do that, I have 2 times the quantity of t squared minus 7t minus 2 all over 2t minus 7 squared. The product is negative 2. The sum is 7, not factorable, so it will not simplify. So I am done. I'm just going to leave it like that. Number 11, you're still taking the derivative using the quotient rule. So again, doing the quotient rule, I'm going to leave my denominator alone, take the derivative of my numerator, so the derivative of sine of x is cosine of x, minus, now I'm going to take the derivative of my denominator, so I'm going to leave my denominator alone, so that will be sine of x, and take the derivative of my denominator and get 2x. I think I said that wrong, but I'm doing it right. And this will be all over x squared squared. Now when I simplify up here, I'm going to have x squared times cosine of x minus 2x sine of x. And this is all over x squared squared, which will be x to the fourth. In the numerator, I realize that I have a common factor of x, so I'm going to factor that out. So I'm going to be left with x times cosine of x minus 2 sine x all over x to the fourth. Now the x's can simplify, so this x will go, and this will be x to the third. And that's going to be my final derivative, as x times the cosine of x minus 2 sine x all over x to the third. If you can simplify, you have to simplify. Number 13, they want you to find the derivative of f of x. So I'm going to find the formula for the derivative, and then they want me to find the derivative at a certain point. So 13, since I'm multiplying, I'm going to have to do the product rule. And then I'm going to substitute in 0 once I find my derivative. So finding the derivative of f of x, I am going to leave the first one alone. Take the derivative of the second one, so this will be 4x plus 3 plus, and then take the derivative of this one, so this will be 3x squared minus 3, and then leaving this one alone, 2x squared plus 3x plus 5. Remember, the product rule is a little bit more forgiving because of that plus sign. As long as you leave one alone, take the derivative of one, then leave the other one alone, and take the derivative of the second one, you're good. So the order of this one does not matter. So here I'm going to multiply, and when I multiply, I'm going to have 4x to the fourth plus 3x to the third minus 12x squared minus 9x. That's multiplying the first two. Now I'm going to multiply these, and I'm going to have plus 6x to the fourth plus 9x to the third plus 15x squared minus 6x squared minus 9x minus 15. Combining like terms, I'm going to have 10x to the fourth plus 12x to the third minus 3x squared minus 18x minus 15. So that's as simplified as it can be. And then to find the derivative at 0, I'm going to substitute in 0 for all these points. So 0 goes there, 0 goes here, 0 goes here. So these are all going to be times 0, which means I'm just going to be left with that negative 15. So the derivative at 0 is just going to be negative 15. And that's all I have to do for number 13. Okay, number 16 is the same direction. You're going to find the derivative, and then you're going to substitute in C once you find the derivative at that point. So I'm using the quotient rule. So I'm going to say derivative of f of x, leave my denominator alone, take the derivative of my numerator, which will just be 1, minus. Now take the derivative of my denominator, so the derivative of the denominator will be 1, and leave my numerator alone. And this is all over my denominator squared. So when I do that, when I distribute my negative sign, because I'm distributing negative 1, this will be x minus 1, when I distribute that 1, minus x minus 1, all over x minus 1 squared. Here, these two simplify, well, equal 0. These two are equal to 0, so I'm left with negative 2 over x minus 1, that quantity squared. And then to find my derivative at this point 2, I'm going to have negative 2 over, oh, it's positive 2, yeah. So I'm going to have 2 minus 1 squared. Well, 2 minus 1 is 1, so negative 2 divided by 1 will just be negative 2. And that would be my answer for the derivative at the point 2. Number 19, these ones they want you to rewrite, then they want you to take the derivative, then you want to simplify. So when I rewrite this, there's different ways that you can rewrite it. But when I looked at this, when I thought to rewrite it, this is still y because I'm not taking the derivative yet. I just factored out a 1/3 to get rid of that denominator. and then I made it x squared plus 2x. That's me rewriting. Then when I take the derivative, I'm going to use that constant times of derivative. So this 1/3 will stay the same. The derivative of x squared will be 2x. The derivative of 2x is just 2. And then I just redistribute my 1/3. So I can either have 2x plus 2 over 3, or you can simplify it as 2/3 x plus 2/3. So this is me rewriting, this is me taking the derivative, and this is me simplifying. Okay, moving on to the next one, number 22, I believe. Number 22, when I rewrite this, I'm going to do two things. I'm going to think of this as 4/5, get that constant out of the way, and then instead of writing 1 over x squared, I'm going to write it as x to the negative 2 power. So I'm going to rewrite it like this. Then when I go to find the derivative, that 4/5 just stays on the outside. I'm going to take my power, which is negative 2, and I'm going to multiply it, and I'm going to take this negative 2, and I'm going to subtract 1 from this, so this will be to the negative 3 power. So when I multiply, I'm going to have negative 8/5, and then this is times x to the negative 3rd. Have to rewrite it without a negative exponent, so I'm going to say that I'm going to have negative 8, and that x to the 3rd will go in the denominator with the 5, and that'll be my final answer. Okay, number 25 says find the derivative of the algebraic function. So you're going to take the derivative. I have a quotient, so I'm going to use the quotient rule. So when I go to take the derivative, I'm going to leave the denominator alone. Take the derivative of the numerator. So the derivative of 3 is 0. The derivative of negative 2x will just be negative 2. The derivative of negative x squared will be negative 2x minus. Now I'm going to take the derivative of the denominator, which the derivative of x squared is 2x. The derivative of 1 is 0. And then multiply it by the numerator. And this is all over my denominator squared. So then when I multiply, so I'm going to have to simplify it. So I'm going to multiply this x squared times this negative 2 minus 2x. And when I multiply the first two, I get negative 2x to the 3rd minus 2x squared plus 2x. Oh, probably should have factored out 2. Didn't think to do that. Now I'm distributing the negative 2, so this will be minus 6x plus 4x squared plus 2x. Oh, yeah, 2x to the 3rd. And this is all over x squared minus 1, that quantity squared. Now what can simplify? Well, this negative 2x squared to the 3rd and positive 2x to the 3rd will equal 0. And I think that's the only thing that will equal 0. Now combining like terms, I'm left with 2x squared minus 4x plus 2. And this is all over x squared minus 1, that quantity squared. Well, I need to make sure that nothing simplifies, so I am going to factor out 2 in the numerator. And when I do that, I'm going to have 2 times the quantity of x squared minus 2x plus 1, which I recognize. I hope you recognize. This, does everyone agree that x squared minus 1 factors is x plus 1? X minus 1, but since it's squared, they're both going to be squared. So the numerator, I believe, will factor as x minus 1 squared. That's how I factor the numerator, and this is all over x squared plus 1 squared, x squared, x minus 1 squared. Then these two can simplify, and my final derivative is going to equal 2 over x plus 1, that quantity squared. Hopefully you remember all that algebra. All right, the next one, find the derivative algebraic expression. Before I begin this one, I'm going to rewrite it. To be perfectly honest, I probably wouldn't even use a quotient rule to do this, but I'm going to go ahead and use a quotient rule. If I think of this, this is 2x plus 5 over x to the 1/2 power. That'll make it easier for me to find the derivative. I'm wondering though, well, we'll do it this way and then we'll do it the other way. So if I do it, we're using the quotient rule. I'm leaving my denominator alone, taking the derivative of my numerator, which will just be 2, minus taking the derivative of the denominator, which will be 1/2 times x to the negative 1/2. And then I'm going to leave the numerator alone. And this is all over x to the 1/2, that quantity squared. So when I do this, I get 2x to the 1/2. And then when I distribute this, I'm going to minus the 1/2 times the 2 is 1. X to the negative 1/2 times x to the first will be x to the positive 1/2. And then this will be minus 5 times the 1/2 will be 5/2. X to the negative 1/2. And this is all over x to 1/2 squared, which will just simply be x. Then if I have this, these two are like terms. So when I combine my like terms, I'm going to end up with a 1x to the 1/2 minus, and then I'm going to write this as 5 over 2x to the 1/2. And this is all over x. So if I wanted to get rid of that fraction with the fraction, I would probably, this is my common denominator, or my lowest common denominator, 2x to the 1/2. I would probably multiply both the numerator and the denominator by the 2x to the 1/2. When I do that, the 2 times this 1 will be 2. And then x to the 1/2 times x to the 1/2 will just be x. Here they will simplify, so I'm left with minus 5. And then here, 2 times 1 would be 2. And then x to the first times x to the 1/2 will be x to the 3/2. So that's my derivative. But I'm wondering, I wonder if anyone thought to simplify it. Since this is a monomial, I could have thought of this as 2x plus 5. I'm just rewriting it. I'm not taking the derivative yet. Over x to the 1/2. Then if I go term by term, this is 2x over x to the 1/2 plus 5 over x to the 1/2. Everyone's with me, I hope. So this would be 2, and then 1 minus 1/2 would be just 1/2. And then rewriting this, I would have 5 to the negative 1/2 power. Now, if I take it part by part, term by term, when I take the derivative, I'm going to have 1/2 times 2, which is 1, and then subtract 1 from 1/2, which will be negative 1/2, plus, oh, where'd it go? That's my family. Glad to get to solve them. So this is 5 times negative 1/2, so that'll be negative 5/2. And when I subtract 1, that will be x to negative 3/2. And then I can rewrite it as 1 over x to the 1/2 plus negative 5 over 2x to the 3/2. And you could say, well, that doesn't look like this. But yet, if I wanted to make it look like this, I could multiply this by x to 1 and x to 1, because then they would have a common denominator. So this would be x minus 5 over x to, what do I have to, yeah, I have to do 2, don't I? Yeah, 2. 2, because of that 2 right there. So 2x minus 5 over 2x to the 3/2. So I don't know which way is easier, but there's both ways in case you want to know. This one, it's asking me to find, I can use, again, I could use the product rule, which I did when I was doing these before, or I could actually multiply that out. So let's just say you use the product rule, because that's what I did the first time. So if I do the product rule, I'm going to leave the f of x alone, take the derivative of this. So remember, this is actually x to 1/3, which I'm going to write that, if you don't mind. So I'm going to write that x to 1/3. Okay. I'm leaving that alone. I'm just rewriting it. And now this is x to 1/2. So when I take the derivative, that's going to be 1/2 times x to negative 1/2. And then the derivative of 3 is just 0. Then I'm going to have plus, because it's product rule, and then I'm going to do 1/3 x to the negative 2/3, because 1/3 minus 1 is negative 2/3, and then I'm going to leave this alone, so x to the 1/2 plus 3. Then simplifying, 1 times 1/2 is 1/2. Then 1/3 plus a negative 1/2 is negative 1/6. So this is x to the negative 1/6. Then here's the 1/3, so plus 1/3. And then add negative 2/3 to the positive 1/2. When I do that, I get negative 1/6. And then 1/3 times 3 is 1, so this will be plus x to negative 2/3. These two are like terms. So when I add 1/2 to 1/3, I get 5/6. Then this is x to the negative 1/6 plus x to the negative 2/3. Then here I'm going to rewrite so I don't have that negative exponent and have 5/6 times x to the 1/2 plus 1/x to the 2/3. And I can leave it like that. I can put it back in radical form. I would probably just leave it like that. Okay, moving on to the next one. Okay, number 36, you're finding the derivative and you're multiplying three things times each other. So in order to find this derivative, there's two ways to do it. One way is if you leave these all as products, you're going to say the derivative, and we'll just go in order. I'm going to take the derivative of the first one. So the derivative of the first one will be 2x minus 1. Leave the other two factors alone. Then I would, to do the second term, I'm going to take the derivative of the second term, or the second factor, I should say, not term, second factor, and then everything else stays the same. So this will be x squared minus x, and then taking the derivative of this will be just 2x, then x squared plus x plus 1. And then finally, the last term would be taking the derivative of this and leaving the other two factors alone. So here's a plus sign. I ran out of room. Everyone's going to run out of room. This is a long problem. We have x squared minus x squared plus 1. And then taking the derivative of this would be 2x plus 1. And then I would FOIL all those out. That's a lot of work. So if I can, I choose not to do that. So what I did is I'm just going to draw a squiggly line to say that I'm going rogue here. And I multiplied these two first. So when I multiply, because it's just taking a binomial times binomial, that's pretty easy to do. And this isn't derivative, this is still f of x. So when I multiplied those two together, I got x to the fourth minus x to the third plus x squared minus x. And then I left that one alone. And now I can do the product rule with just two things, which I think is a lot easier than doing it with the three. So I'm going to continue my work from here. So now I'm going to take the derivative. So when I take the derivative, I'm going to leave this x to the fourth alone. I'll put a parenthesis around that. And now I'm going to take the derivative of the second term. And when I take the derivative, second factor, why do I keep on saying term? This will be 2x plus 1. There's a plus sign. Now I'm going to take the derivative of this. So this will be 4x to the third minus 3x squared plus 2x minus 1. And then leaving that one alone. And then I'm going to multiply. And when I multiply, I get, when I multiply this times this, I get 2x to the fifth minus x to the fourth plus x to the third minus x squared minus x. And then when I multiply these two, I get 4x to the fifth plus x to the fourth minus the third plus 2x squared plus x minus 1. Combining my terms, I end up with 6x to the fifth plus 4x to the third minus 3x squared minus 1. That one was probably the most work out of all the problems for the homework. Okay, in the exercise, you were trying to find the derivative. In 39 and 40, we start bringing the trig in. So it's asking me to find the derivative of t squared times the sine of t. So I'm going to do the product rule. So I'm going to leave the t squared alone. Taking the derivative of sine will be cosine t. Then plus the derivative of t squared will be 2t. And then I leave the sine alone. Here I can see that I can factor out a t. So when I factor out a t, I'm going to have t times the quantity of t cosine t plus 2 sine x. Oh, it should be t. Sorry. That's a t. That's pretty simple. So then to do the next one, going term by term. So I'm going to say the derivative of x is 1. Then the derivative of cotangent is going to be negative cosecant squared x. So my derivative will just simply be 1 minus cosecant squared x, which I'm wondering, yes, I wonder if you guys remember your Pythagorean identities, and this is going to actually equal a negative cotangent squared x. So I wonder if you remember those. Okay, the next one, 47. I did it using the product rule, and I got a different answer than the back of the book. The back of the book, what they did is they separated this, and they did like 1 over cosine and sine over cosine. I did not do that. I did the product rule or the quotient rule, and I like my way better, so I'm going to stick with it. So I would probably just bring out that 3/2 because it is a constant factor, and then I cannot, if this isn't the derivative yet. And so I'm just going to rewrite it where I pull out that 3/2 so I don't have to worry about it. So I'm just going to multiply that times my derivative. So here's the 3/2 that I bring out in front. Leave the denominator alone. And then take the derivative of the numerator, which is just going to be cosine, negative cosine of x because of that negative sign there. Minus, and now I'm going to take the derivative of the denominator, so the derivative of cosine is negative sine x, and then I'm going to multiply it by the numerator, which is 1 minus sine x, and this is all over my denominator squared, which I guess I'll write like this the first time. Then I leave that 3/2 out in front. Cosine times cosine will be negative cosine squared x. And then this negative times this negative, we can, negative times a negative will make that a positive. So I'm just going to distribute a positive sine x. So this will be plus sine x minus sine squared x. And this is all over cosine squared x. Then, still leaving out that 3/2. Think of this way. Here, these two are both negative. So think of having a -1 times cosine squared x plus sine squared x. I just wrote those two next to each other. I'm only factoring out from the first, those two terms, and then I have the plus sine x here. And this is all over cosine squared x. Now, from this point on, this is not calculus. This is like trig and algebra work that I'm doing. So here's 3/2. I'm still bringing along. This cosine squared plus sine squared, remember, is equal to 1. So this will be -1 plus sine of x. And then, whoopsie, bracket. And then cosine squared x, I'm going to rewrite as 1 minus sine squared x. Again, Pythagorean identity, you should remember that. Because I realize that I can simplify it. So I'm going to go painfully slow here. And I'm going to factor out a -1 here, which will make this a positive, this a negative. So I'm going to have 1 minus sine x. And then here that factors as 1 plus sine x, 1 minus sine x. Now I can see that the 1 minus sine x is simplify. So my derivative is going to be left with 3 times -1, which is -3, over 2 times the quantity of 1 plus sine x. And that's my final answer, as simplified as I can be. Okay, next one. 51, you're multiplying, so we're going to use the product rule. So I am going to leave f of x alone, take the derivative of tangent, which is going to be secant squared x, plus derivative of x squared will be 2x times tangent of x. Then from here, when I look at here, I am going to factor out an x to make it x times the quantity of x secant squared x plus 2 tangent x. I thought about factoring out a secant x, but then I just stopped myself and said, no, this is good enough. So there I am. That's my derivative. Very simple. And then 59. So this one, it wants me to evaluate the derivative of the function at a given point. So I'm going to, and then use a graphing utility to verify. I never really use my graphing utility. Although I'm sure someone has told you that you can find a derivative on your calculator, you hit the menu and then calculus and then derivative at a point. And maybe the next video I'll show you how to do that. But here we're just going to practice. So I am going to leave my denominator alone. So 1 minus cosecant x multiplied by the derivative of the numerator. Well, the derivative of 1 is 0. The derivative of cosecant x is negative cosecant x times the cotangent of x. And then this will be a minus sign. Now I'm leaving my numerator the same. And I'm taking the derivative of my denominator. So this 1 is 0. So then I'll have this negative sign. And then the derivative of cosecant is a negative cosecant x times the cotangent of x. That's a lot of parentheses. And this is all over 1 minus cosecant x squared. So when I multiply, so I'm going to multiply this times this. I guess that's the way I'm going to do it. So I'm going to have a negative cosecant x, cotangent x. Then negative times a negative will be positive. So this will be cosecant squared x times cotangent of x. Here I'm multiplying this times this going backwards, but then this negative, just showing you how I'm doing this, this negative and this negative, whoopsie, this guy right here, will be a positive, right? So then when I distribute this, the negative times the 1 will be a negative cosecant x cotangent x, and then the cosecant times this negative will be a negative cosecant squared x cotangent x. And this is all over 1 minus cosecant x, that whole quantity squared. So these two are opposite signs, so they will equal 0. And then I have this term and this term are like terms, and I have 2 of them. So I'm going to write negative 2 cosecant x cotangent x all over 1 minus cosecant x, that quantity squared. And I think that's as simplified as I can get it. So then what I'm going to do now is I'm going to substitute in the point that x is equal to pi over 6. So I have to find the cosecant of pi over 6, and I'm willing to bet most of you don't know that. So cosecant of pi over 6, probably don't know that off the top of your head, but you know cosecant is a reciprocal of sine, I hope. So then the sine of pi over 6, sine of pi over 6 is 1/2, which means the cosecant would be equal to 2. And the cotangent of pi over 6 is equal to cosine of pi over 6 over the sine of pi over 6. So this will be the square root of 3 over 2. This is 1/2. The 2's will simplify, and that's the square root of 3. So what I'm doing here is I'm taking -2 times the cosecant, well, I guess I should write it, cosecant of pi over 6 times the cotangent of pi over 6. And this is all over 1 minus the cosecant of pi over 6, that whole quantity squared. So what does that mean, you ask? Well, let me tell you. So this is -2. The cosecant of pi over 6 we said was 2. The cotangent of pi over 6 we said was the square root of 3. Then this is 1 minus the cosecant of pi over 6 we said was 2, and this is squared. So multiply my numerator, that will be -4 times the square root of 3, and this is all over -1 squared, which will just be 1. So my answer is -4 times the square root of 3. So that is my derivative at pi over 6. And that finishes the homework, and I hope this was helpful, and we'll see you soon.